Hello guys, you are welcome to this class. In this particular video or in this particular class, we are going to be discussing frictional force. So this is No My Science Just Online. I remain Dr. Michael, and please, if you have not subscribed to this channel, please subscribe to this channel. Click on the subscribe button and also click on the notification button. Then click on the bell that has a ringing chip so that whenever we upload a new video, YouTube will notify you. Also, you can reach us via our WhatsApp number that is showing on your screen. Please, if you like what we're doing, just give us a thumbs up, comment on the comment section, and then give us a like, right? Then invite your friends too so that they can come and enjoy this wonderful class. Is that okay? So we are bringing physics lecture direct to you at your very doorstep. So today we are looking at frictional forces or friction. Yeah, we're discussing frictional forces, right? So welcome to the class for today, and then let's go. Okay, so we are looking at friction. So what is friction? In our previous class, we mentioned, or when we discuss causes of motion, we mentioned friction, and we said that frictional force is that force that opposes the motion between two bodies that are in contact. Is that okay? So when two bodies are in contact and you want to pull them over one another, the force that opposes their motion is called frictional force. Is that okay? So frictional force, the force that acts in such a way that it opposes the motion between two bodies that are in contact. So frictional force is the force that acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. Is that okay? So when two bodies are in contact, like a block of wood on a top of table, right? The two bodies are in contact. So if you want to move one over the other, maybe you want to move the block of wood, right? You see that there's an equal and opposite force that is trying to oppose your motion or trying to oppose the effect that you want to impart on the block of wood. That opposing force is called frictional force. That opposing force is called frictional force. So examples of frictional force where you can have it is one, walking. Walking is made possible because of the frictional force that exists between the soles of our shoes and the ground. Without this frictional force, we cannot walk smoothly. Just imagine walking on a slippery surface. You know that because the surface is slippery, the frictional force between the soles of your shoe and that ground is reduced. So because of that, walking becomes difficult for you. Is that okay? But if the ground is not slippery, then there will be enough grip and then you can now walk freely. So that is one area where frictional force applies. Also, to hold two pieces of wood together, for a nail to hold two pieces of wood together, they require frictional force. Is that okay? So frictional force enables nails to hold pieces of wood together, right? So we have two types of forces, or frictional forces. Okay, so the frictional force between two solid surfaces is known as solid friction, while that between liquid surface is known as liquid friction or viscosity. So this we have discussed before in our previous lecture. It's just like we are trying to repeat it and then for you to get a better understanding. So we have two types of frictional forces, right? We have solid friction or static friction or limited friction. Then we also have dynamic or kinetic friction. Is that okay? So those are the two types of friction. We have solid friction, static or limited frictional force, and then dynamic or kinetic frictional force. So what is static or limiting frictional force? That is, what is static or limiting frictional force? So to demonstrate static or limited frictional force, we can have this simple arrangement, right? So this is a block of wood, and then this is a spring that is tied to the block of wood. Then you have the block of wood on a table. Let's put like this. This is a table. Then if you look at this arrow, this is a force that will try to pull the block of wood. Then this is a reaction force, or this is an opposing force, a frictional force that is acting opposite to the force that we're trying to pull the block of wood. Then because the wood is resting on this table, the weight is acting downward, right? The weight of the wood or the block of wood is acting downward, while there's also an equal but opposite reactional force that is acting upward, and that is what is labeled as arrow here. Okay, so to demonstrate static or limited friction, this setup is arranged simply like this. So a block of wood is placed on top of a table with a string attached to it as shown, right? So this is the weight of the wood, and then this is the reaction force on the of the wood of the table on the block of wood. Is that okay? So now when you have this type of arrangement, if you apply a small pull gradually on this block of wood, you find out that the wood will not move. This block of wood will not move. But as you continue to increase your force or the effort on this pull or this string on the block of wood, at a particular point in time, this block of wood just begin to slide. So the maximum force required for the block of wood to just begin to slide is what is called limiting or static friction. So for this block of wood to start to slide, it means that this effort has overcome this frictional force. So that force, that maximum force that is needed to overcome this frictional force is what is called limiting frictional force or static friction. Okay, I hope that is understood, that when you begin to pull this wood, initially it will not move, but at a certain point in time, the wood will just begin to slide. That point at which the wood begin to slide, the force that is needed to overcome that frictional force that is opposing that motion is known as limiting frictional force or static friction. So the static friction is the maximum force that must be overcome before a body can just start to move over another. You know that before this body can start to move, this effort must overcome this frictional force. So that maximum force that is required that must be overcome for this body to start to move is what is called limiting frictional force or static friction. That okay? So when we solve problems on this, you see how it is applied. So that is what is called static or limiting frictional force, right? So what about dynamic or kinetic friction? Dynamic or kinetic friction. You know that once this block of wood that we described earlier begins to move, once it starts to move, the frictional force now between the block of wood and the surface is reduced, because you don't need too much force again to continue to roll the block of wood anymore. So the dynamic or kinetic friction is that frictional force that exists in a body that is already in motion. So like I said before, when the block of wood starts moving with uniform speed, when the block of wood starts moving with uniform speed, the frictional force opposing motion is known as sliding, kinetic, or dynamic friction. So kinetic or dynamic friction is friction that exists on a body that is already in motion. And if you look at it, you find out that dynamic friction is actually less than static friction, right? Dynamic friction is actually less than static friction, because dynamic friction is friction that exists on a body that's already in motion, while static friction is that frictional force that is required to that must be overcome before a body can just start to move. So dynamic friction is less than static friction. Is that okay? So that is what is called dynamic or kinetic friction. Now, for frictional force, or for limited frictional force, from the laws of friction, limited frictional force is directly proportional to the normal reaction between the two surfaces, and this is mathematically stated as this: limited frictional force is directly proportional to the normal reaction. Now, this constant of proportionality, if you write it mathematically, it becomes F is equals to mu times R. This mu is called coefficient of friction. So the constant of proportionality, mu, is equals to, if you make it a solid formula, is equals to the limited frictional force, or frictional force all over normal reaction. So frictional force all over normal reaction is equals to what? Coefficient of friction. Coefficient of friction. So from our discussion, we have been able to know that frictional force is that force that opposes motion. Frictional force is that force that opposes motion, and that static friction is the force or the maximum force that must be overcome for a body to just begin to move. And we also see that friction is applied to walking easily, to driving of nails through wood. Then dynamic friction is the friction that exists on a body that is already in motion. A body that is already in motion has a dynamic or kinetic friction. Then we've also seen that limiting frictional force is directly proportional to the normal reaction, and mathematically stated, the constant of proportionality is known as the coefficient of friction. The constant of proportionality is known as the coefficient of friction. I hope this understand, because this is the introduction to friction, and in our next class we are going to talk about different areas where friction is applied, and then we'll look at the laws of frictions, advantages of friction and disadvantages of friction. Then we're going to solve calculations on frictional forces. So thank you for this. Thank you so much for listening, and then we'll continue to bring up more videos for you to, or more lectures for you to enjoy. So guys, thank you so much. We appreciate your time. Please, if you have not subscribed, just subscribe to this channel and also click on the notification button. If you have any concern in physics, please don't hesitate to reach us via our WhatsApp number that is showing on the screen. Also invite your friends so that they can come and enjoy this wonderful class that you are also enjoying. Give us a thumbs up or a like so that you continue to encourage us. At least encourage us now. Give us a like so that we'll continue to bring up more videos while bringing physics direct to your very doorstep. So thanks so much. We are going to see you in our next class. You are welcome.